Folks, so this is Chapter 10, Part A of the Muscular System, and I really just want to talk about this part of Chapter 10 because there's a lot to talk about as far as muscle names, the actual physical anatomical structure name of muscles, which again we'll cover a little bit towards the end of this PowerPoint, but that really gets covered in lab, so we won't pay too much attention as far as names. We will in fact actually look at the classifications and the criteria used to actually name these muscles. So that's part of which we'll discuss in this PowerPoint. So when we look at muscle action, right, muscle tissue encompasses not only skeletal, but we're talking about cardiac and smooth, right? So again, we don't mention that here per se, and we don't discuss that per se. We mention it here, but we won't discuss it per se in cardiac and smooth muscle. We really discuss that more so when we get into the cardiovascular system and the second part of anatomy, physiology, and smooth muscle. When we get into digestive system in anatomy and physiology too, right? So again, our focus here for skeletal is skeletal muscle, and in that regard, we look at really how muscle brings movement, right? So we'll discuss that, the criteria, and we'll look at what we call leverages or levers, right? Which is actually using a little bit of physics to apply force and watching that force be applied to an object being moved, whether that be the body part or if something's weighted on the body, lifting that up. And so we'll get to see how that works, you know, in the levers, right? All right, so a muscle can only pull, it can never push, so we're only pulling per se a muscle, so we're never pushing per se, right? When we look at muscle groups, we'll see that a muscle group will do something, and while the other opposite muscle group will undo something. So if we are, for example, lifting up something, let's say using our example that we've been using, the biceps brachii muscle, and if we're lifting up something using that muscle group will do that lift, right? In the regard that that muscle and its opposite will do the opposite effect. So if biceps brachii muscles are lifting, then the role of the triceps brachii muscle is to lower that object, right? So we're talking about, you know, if something does lifting, the opposite does placing down, or placing down, then lifting. So very much so that we've got these groups per se that do this, right? They act as opposites. And that's really where we're getting into as far as talking about these functional groups, these three main functional groups that we discuss where muscle falls into, right? So a muscle can be a prime mover. We call that an agonist, right? This is the one that's responsible for producing a main type of specific movement in the body, right? And so we would talk about this muscle being a prime mover, the one that's majorly responsible for doing this specific job. Lifting the leg, lifting our body, standing up, lifting our arms, right, in different directions. There'd be prime movers that are involved in doing that. The antagonist does the opposite, basically, or reverses whatever movement that the prime mover is doing. So again, we mentioned the biceps brachii muscle being a prime mover in lifting something with your hand. And conversely, we have the antagonist, which is the triceps brachii, that do the opposite. So if we're lifting something with our hand, we're lowering it down with our tricep, right? The prime mover in that example is the bicep. The antagonist would be the tricep. So the prime mover and the antagonist are always located opposites of the joint in which they act, right? So that's a great example. So we're talking about moving our elbow, if you will, right? In that regard, when we're talking about lifting something with our hand, lowering it down using our bicep and tricep, And so the bicep would be located, anatomically speaking, on the anterior side, and the tricep would be located on the posterior or back side. Great example of what you see there, prime mover. We also have synergists, and synergists actually are assisting prime movers. So they don't do the major role of the lifting, nor do they do the major job of lifting, but they do assist, right? So they can add extra force. They can reduce unnecessary movements, or very much so stabilize the joint to allow the prime mover to do its job. And so a type of synergist we call a fixator. It immobilizes the bone or the muscle's origin. And this is what we talk about when we talk about stability, right? This is a stabilizer, right? So some synergists can add extra force to lift heavier things, objects. Others can act as fixators or stabilizers, stabling while the prime mover is doing its job. Okay? So what we're looking at in figure 10.1a is just an example of how the pectoralis, right? Pectoralis major muscle. We call that a pec, right? What our pec muscle does. And you can see, for example, that major fanned muscle here that makes most of our chest is attached to the upper portion of the humerus, and when we contract that muscle, we produce then flexion, and you can see the arrow kind of going up, right, on the anterior. So what is another muscle? So that's a prime mover in that example. So what about the backside, right? Our latissimus dorsi muscle, big old lats, right? This would be the latissimus dorsi, right? Or we would commonly know that to be the lats. If you're working out your lats in the gym, right? Be working out that big fanned muscle. We'd call this wings as well. That's a weightlifter lingo there, right? But wings, right? And so what does that do? It's also attached to the backside of the humerus, and when it contracts, it pulls the arm back or extends the arm back. Sometimes hyperextends it back, right? You see that in that example, right? This is acting as an antagonist. Now, just a side note that you have to understand is that not all muscles are going to be prime movers all the time. Sometimes they act as antagonists, and not all muscle groups act as an antagonist all the time. Sometimes they'll be prime movers. So they do double roles, right? So it just depends on what we're going to initially do with the movement. Is our initial movement extension or is it flexion in this example? If the initial movement is going to be extension, then the latissimus dorsi muscle in our example here is the prime mover. And our pectoralis major muscle is our antagonist if we want to swing the arm back. You can use the same example and say, we have the body in anterior position, anatomical position, and my initial move with my arm is to swing it forward or flex. And so the prime mover there is going to be our pectoralis major muscle, and our antagonist is going to be our latissimus dorsi muscle. So they get interchanged is what I'm trying to say here, okay? So we see here, right, this is the deltoid muscle, just giving us another example. If we're using the deltoid to abduct, which means move the arm this way or swing the arm up, this is what we see here. By contracting that muscle, it's going to pull the humerus and the arm all the way up. And then we can have adduction, which does the opposite, right? this muscle, the teres major muscle, which is part of your shoulder, will pull the arm back, right? Again, the abductor, the deltoid is our prime in that example, and then immediately following is our teres major muscle, which is our adductor, which is our opposite. Okay? So again, this is what it means, right? Prime movers, you know, same exact muscle can act as a prime mover in one direction. If it's doing the opposite, it can act as an antagonist. Sometimes it can be a synergist even. So they do triple duty, right? Depending on what the muscle's doing at the time. Biceps, for example, can act as a prime, can act as an antagonist, or it can act as a synergist. Not all at one time, not all for one movement, but it can do many. Okay, so let's use the criteria here when we name muscles, and let's see if we can kind of see some examples of this. So let's look at how we do this, right? Muscles can be named for the location of where it's found, right? And what we mean by location is basically, for the most part, where the muscle's found over a certain body area, region, or a certain bone. For example, when we talk about the temporalis muscle, the temporalis muscle is named the temporalis muscle because it's located over the temporal bone, which is located basically your temple, right? So we use that word temple area. Side of your head, right? Temple. Muscle can also be named for shape, right? So sometimes we look at the muscle and it has a certain shape, like the deltoid. Deltoid means delta, which means triangle. And in fact, if you look at the side of the shoulder, so if I'm looking at the lateral view of the shoulder, that muscle resembles a triangle, upside down triangle in fact, but it's a triangle nonetheless. Now, does it have perfectly lined, sharp lines, right? It does not. It's rounded, of course, but it resembles a triangle, and that's what we call it, a deltoid, right? And also muscle size, how big or how small the muscle. And we give some great examples here: maximus, minimus, longus. And so you'll see these words commonly used in muscles when we study muscles, right? Like the gluteus muscles, or use a common term here, right? Your butt muscles, right? Which in fact are not just one whole muscle, but in fact there's three muscles that make up your gluteus muscle. Okay. We also can name muscle depending on the direction of the muscle fibers. And remember, keep in mind that muscle fiber, whenever we hear the word muscle fiber, that should automatically equal a muscle cell. And depending on the muscle, sometimes the muscle fibers can go a certain direction, right? So these lines represent them. If we looked at a muscle and looked at these, individual muscle fibers, we could see the muscle fibers having a certain direction, right? So it just depends. Sometimes the fibers of the muscle cells run up and down, rectus. Sometimes they run at a right angle, transversus. And sometimes they run at an angle, which we call an oblique angle. And all of these, for example, can be found in that, right? Tire, right? Transverse abdominis muscle, internal abdominis muscle, rectus abdominis muscle, and external abdominis muscle. These will all be considered your abs or your ab muscles. So when you see somebody with a nice little six-pack and the nice little muscles that run in an angle. That's what we're talking about, because we're talking about each type, each set, these 4 sets of muscles that make that really abdomen muscles and their direction of the fibers. So I hope that gives you a good example of what you see there, right? And finally, the number of origins. So we look at muscle in the fact that it has certain numbers of origins. Most of them have 1, but some of them have more than 1 origin group, right? And so the bicep, the reason why we call it bicep is because it does have 2 origins. So bi means 2, resembles 2, right? 2 origins. And tricep means 3, right? 3 origins. Okay? So number of origins is also a criteria for naming muscle, right? And so we look at also the point of attachment, where it's located, right? Where the point of attachment is going to be. And so we can see here, right, sternocleidomastoid muscle. There's actually 3 words here. Sternum, cleido, clavicle, mastoid process, right? It's on the face, right? And then the action of the muscle. What's it going to do with the movement, right? And so there's specialized muscles that do specialized movement, like flexor extensor muscles. You would see those on the forearm, for example. The ones that you can point your fingers up and down, right? You can flex and extend your whole wrist, if you will. And those are because of these muscles, these groups of muscles found in your forearm that lift your whole hand up and drop your whole hand down, right? Okay, so let's talk about fascicle arrangements, okay? So we know that skeletal muscle, because we've seen this in chapter 9, we know that muscle fibers and muscle cells are arranged in these and bundled together in these what we call fascicles, right? Groups of muscle fiber binded together by connective tissue, right? And these arrangements can vary, right, depending on, where they're found and what they're used for. And so we see different shapes because of the bundles of these fascicles of this muscle around the body, right? So here's the most common arrangements. There are some other ones you could see if you really wanted to look at, but this figure 10.1 that we're looking at in the book, and also what we've asked to study on in lab, discusses those major common ones, right? So I'd like to just cover a couple of them, but if you look at this one, circular, right, forms a circle, right? The fascicle kind of makes an oval shape appearance or circular appearance, and you can see that, for example, in the mouth, orbicularis oris muscle, that actually closes our mouth, right? Helps our mouth pucker, for example. Okay, moves our lips, right? And let's look at this one, right? Convergent, right? So we've got a whole bunch of muscle fascicles kind of converging onto one area, basically. So if this was my convergent muscle, it would converge to one point, right? This would be the tendon at the end, right? So this PowerPoint, what I wanted to do is just kind of give you examples and each of those patterns, just so you know the arrangements there, right? Give you some examples to go by so you can see in each one. So here, let's move on to levers, right? Levers. Skeletal muscle moves, right, or causes movement using a leverage system or levers, right? When you apply force to something, will cause something else to move if that force is connected somehow, right? And a lever system really is a connection, right? And we're using not only muscle, but we're using bone, and we're using other things like sometimes tissue to actually cause this movement. Okay, so a lever really is composed of three major things, right? The lever itself, the effort, the force applied, and the load, right? Let's take each one, right? The lever is usually a rigid bar, okay? A rigid piece of material. And if we're moving muscle that we're doing in the body, our rigid bar, if you will, is a bone, because levers can be used in other things. And so we're going to use real life situations where you would use levers. But that's a very good example of what you see in the body, right? So our bone is our lever, right? That bone, if you will, that bar, if you will move in on a fixed point. And that point is what we call a fulcrum, right? Fulcrum. And our fulcrum in our body is going to be the joints. That's the movement of the bone on a fixed point. Okay? Now our effort is the force, right? That's the force applied to the lever, right? That force is supplied by the muscle. When we contract, we generate force against the lever or the bone, causing the bone to move on the joints, then causing movement, right? The load is the resistant. Any kind of weight, any mass that we need to use to actually move, apply force to and move by the muscles is called the load. Now, this can be the bone itself, tissue, or if we're putting on weight, let's say we're adding a dumbbell to our hand and causing and asking ourselves to flex our bicep, right? That can all be considered the load, right? So what does a lever do, right? Allows effort to move a heavier load or to move a load farther, faster, right? Using a fulcrum and a lever system actually helps us do that. And that's how we can actually multiply the amount of load we can lift and push and what have you, right? So what kind of lever would you like, right? Depends on what you're doing. Do you want the mechanical advantage? Do you want the power lever, right? Where the load is really close to the fulcrum. The effort is far away. The muscle's far, where the force is far away. That can move a large load. That can be a power one. Can lift things that's really heavy. Or do you want it for speed, right? Call it a mechanical disadvantage, where the load is farther away from the fulcrum, the effort is close to the fulcrum, and you're going to cause the speed lifting, right? Depends on what you, in this example, closer the fulcrum is to the effort, the greater the speed and the less it's going to be used for power. Okay, so our first class lever is where the fulcrum is between the load and the effort. A seesaw is a great example, right? Picture your seesaw here, right? Somebody here, excuse my little man, woman, person, and there. This could be the effort. This could be the load, right? Causing the lifting of that person. Effort's going to be pushed down, whether it be the weight or somebody jumping on it, right? Causing that to happen. Scissors do the same thing, right? Do the same thing. Except we're using two seesaws in one, basically. But the effort is applied here, down, causing scissors to cut up or down, causing the load to, force to be applied there on the load. So what about a real world situation, right? Look at that, right? Here's a joint between the skull and the vertebra. The load is moving the head, right, back. That's the effort applied by the muscle on the fixed point, causing the head to go back. Talk about flexion and extension, right? Maybe this is hyperextension, causing him to go way back. Moving the weight of his face here up. Right? First class lever. What about the second class lever? Load is between the fulcrum and the effort. And so we see this, for example, in a wheelbarrow or standing on your toes. The example of choosing your body, but look at that, right? Here's your fulcrum. Your fixed point is right on that tire, right? Where's your lever? It's your piece of wood, piece of stick there, your handles, right? And what's the effort? Effort's the person lifting that up, right? Where's your load? Right in the middle. That's the weight, right? The soil, dirt, cement blocks, whatever that might be. All really powerful movements. Look at this, right? Here's the fulcrum. Again, here's the load, and here's the effort. Go ahead and write that out in the test if you need to while you're going through these, if you see these questions, right? Here's the muscle, right? Muscle's up. Load's going down, right? It's the weight of the body. And right on the fulcrum, what's our lever, right? All those bones there. All those bones, right? Right where that red line is. And finally, the third class lever. FEL, right? Effort's right in the middle between the fulcrum and the load. Tweezers are a great example, or forceps. Most of your skeletal muscle works in the third level, or third class lever. Look at that, there's your tweezers there, right? Look at that. There's your fulcrum, there's your elbow is your fulcrum. What's the load? The weight of the rest of the forearm and the hand plus the dumbbell here, right? And what's your effort? That's that bicep muscle going this way, causing the dumbbell to go up. Right? So again, we use these three classes to describe the movement of muscle with the bone causing this movement. Right? Okay, finally, let's talk about these skeletal muscles, right? There's about 600 muscles, right? They're grouped by functional location and also named for that as well, right? All these tables that we have in our book in this chapter include the description of the muscle, where it's located relative to other muscles, its origin and insertion group, the action it creates, and anything that goes into that supplies the muscle that we know exists there, like nerves or blood vessels, sometimes can also be named. So it's a good idea to look at these tables, because when looking at these tables, you get a picture of where the muscle is and what it looks like and where it's found, and et cetera, and that gives you a better way to learn, right? Your brain will pick that up as important information, right? Again, how do we learn muscles? We're going to learn some muscles. Obviously, we've gone through lab, and so we have identified some of these muscles that we need to know, and that's a good majority of them, right? Not all of the 600, but a lot of them. So we got to understand how we get the name, right? Where the name comes from, the root word, and that's important to know first, right? So that's why we have to study those names and the criteria, right? It's really important to identify the muscle in a table, and tables are really important to study. Looking at a muscle model, looking at a table, looking at a figure, and matching it up and pointing it out is really important to learn the information. And then looking at where it's found, and then also its points of attachment and origin are really important. And then acting that muscle out for yourself. Contracting that muscle, feeling the muscle on your skin is an important, a very important exercise when learning these muscles. So that's why lab is important to do that, and that's why we have time spent for get to that. And finally, here's our muscle, right? Here's our muscle man. We call this a muscle man, right? Or muscle woman, right? But here's our muscle person, right? Here's the anterior view. And I've asked you all this semester to study, you know, a good majority of these on the anterior and posterior side. You'll need to be familiar with them. You'll need to memorize these, right? But it helps to work it in that system, right? Reading the tables first, reading the information. Where's this origin insertion group? What's its function? What movement does it create? And then start to look at the name and then where that name comes from. Why do we call it, for example, the deltoid muscle triangle? When we learn these muscles, right? Here's the anterior, here's the posterior view.